Datomic is an append-only database with an architecture inspired by functional programming concepts that enables it to 1. Scale reads, 2. Reduce complexity in clients, and 3. Reduce round-trip problems that we didn't know that we had. And most intriguingly, I think it hints at a different web architecture that includes an in-memory database in the browser.
Yeah, and it is kind of weird that we just accept that data can change from underneath you, right? Like, this is not a very sane or principled way of thinking about data. We've just sort of, again, Stockholm syndromed ourselves into accepting that, we're going to work with systems in which the data can change arbitrarily while we're still working on it.
Hi, this is Will. I'm a YC alumni and independent researcher who's worked across e-commerce, cryptocurrency, and financial industries.
And I'm Shri. I'm a YC alum and a research engineer focused on natural language processing for search.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. Hey Shri, how's it going?
I'm pretty good. How are you doing?
I'm doing all right. Well, so our show has 3 segments. First, we give a high-level outline of what we're talking about. 2, we talk about what it can do today. And lastly, we let our imagination and optimism take over and see how the world would change. So we can't be experts in everything we cover. If you got insights to the topic, let us know down in the comments. And be sure to check out our audio versions on Apple Podcasts or Spotify. So first, what are you drinking today?
I'm pretty good. I have some liquid IV, which I've mixed into a glass here to get some electrolytes.
Oh, it's powder?
It's an electrolyte powder, yes.
It's meant to be like a drip. It should come in a drip bag, right?
Oh yeah, that would have sold.
That would have clinched it, right?
Yeah.
I got Nina, a lightly brewed sparkling tea. I guess it's a pineapple passion fruit flavor. I don't know. It says unsweetened green tea. We'll see how well it tastes, but yeah, I don't know. We'll see. Maybe I should take a swig while we talk about our episode.
Cool. So what are we talking about this week, Will?
This week we're talking about Datomic. Have you heard about Datomic before?
I have seen it before, and I've heard people really enthusiastically evangelize it, but I didn't get a chance to look into it until now, so I'm pretty excited to dive deep with you.
Yeah, same here. So Datomic is an append-only database with an architecture inspired by functional programming concepts that enables it to 1. Scale reads, 2. Reduce complexity in clients, and 3. Reduce round-trip problems that we didn't know that we had. And most intriguingly, I think it hints at a different web architecture that includes an in-memory database in the browser. So, so that should pique your interest, if anything. And so I guess to start off, what does that mean? Like an append-only database and architecture inspired by functional programming concepts. And so I think there's a lot of weird things about Datomic. So one, I think is already that it's written in Clojure. So for people like Lisp or any Lisp variants also have a aura of just weirdness. Like you always hear about it on XKCD and stuff. 2, it's a proprietary database. And so I think in 2022, most everybody's besides Oracle, we don't want to give more money to Oracle if we can help it. And so we would rather have an open source database, but it's proprietary. 3 is that it has single threaded writes, which people are like, okay, if you haven't run for the hills by now, you're just like, I don't know if this is for me. And then even more than that, queries run on the client, and there's no separation between an index and data. The data is in the index. So all of this makes for the weirdness of Datomic. But I think the reason that they have this is because there's some fundamental insights that the creator of Datomic, Rich Hickey, had about the nature of databases. And that's basically where it comes from.
Yeah, I think the main users of Datomic are folks in the Clojure community. And like you said, as with all Lisps, I think they have a very different view of programming, which seems kind of out of sync with the rest of the world, like the mainstream working programmer, right? And it's sometimes hard to understand what they're going on about. And I think that, at least for me, when I first encountered Datomic, I was like, this is some esoteric thing that people are just making up, fake reasons to do things in their weird way. But I think that the mismatch for me, and what made it finally click, was to understand a little bit more about how Clojurians, I guess, the people who write Clojure, think about data and what those principles buy them. And then with that understanding, applying it all the way to the database, then all these weird quirks that you described that Datomic has all of a sudden make more sense. So yeah, maybe we can start from there.
Yeah, so I think one of the best places to start is the fact that it's an immutable database. And the one concept that I think we'll start with from functional programming is immutability. And that means that anytime you have new data coming in, you don't update the data in place. You just keep tacking more and more data to the end of it. And so in functional programming, we think of immutable data structures as being a good thing. And so what are all those good things about functional programming that people in functional programming take for granted with immutable data structures?
Yeah, so I think that immutability, and when we're talking about immutability, it's the idea that when you have some type of data or data structure, like let's say a list or a dictionary or something like that, in most other languages you can update it in place, right? So you can set a key with a new value or something like this. And in Clojure and other functional programming languages, a lot of the time data is immutable in that once you have its value, you can't update it in place. You can make a new copy that mutates it and updates a key, but then the original version remains as it was, right?
Yeah, and so logically, it's like if you want a new thing, you have to make a completely new copy of thing if you want to edit it, so to speak.
Yeah. And I think they do some optimization, so it's not just a pure copy. But we don't have to go into that.
Logically,
but basically,
that's how the way you should think about it.
Yeah, exactly. And so what does it buy you? So I think it buys you a few different things. One is that it's super nice for testing and debugging, because a lot of the time, the thing that makes it hard to reason about your programs is the fact that the state is always changing, right? And so like you have to kind of, if you're writing unit tests in a language that has a lot of mutable state, then first there's certain things that you can't really observe and test properly, or you have to be really disciplined in the way that you structure your logic so that it can actually be tested and observed. And then the other thing is that you get kind of history and version control for your data for free. And this allows you to do things like undo edits or even do some type of time traveling where you can see how a piece of data has changed over time. And so, again, I think this also helps in testing and debugging.
But yeah, I think one of the main things about immutability is that you, as a programmer, can be guaranteed that that thing doesn't change. And so you don't need to worry about data changing out from under you. And so that simplifies a lot of things, like you said. As it turns out, when you kind of think about it, going back from what Elon Musk likes to call from first principles, the fact that we have two tiers of data is almost a historic accident of the technological progress that we had in hardware at the time that databases were invented. Because at the time, memory was expensive, like machines were expensive. And so like if you wanted something to store and query data, which is generally a pretty expensive thing to do, then we would just put it all in one place and buy a beefy server for that, which services everybody else. But then nowadays, we don't really have that restriction. Sometimes even like my laptop is way faster than whatever I spin up in the cloud, right? And so as a result, like this architectural decision of this two-tiered data system has pervaded and introduced all sorts of complexity into web applications specifically. Like I'm sure it's done things in others, but specifically it's kind of created this, what I guess it seems almost like a false dichotomy of a front end back end now as a result. And so if we realize that, what would happen if we could treat the data in our database as an immutable value also? Like what would that look like, and what does that buy us, right? And so that's effectively where they're coming from.
Yeah, and I think there are two things going on here, and Datomic is trying to solve them both at once. Yeah, like you said, it'd be nice if we think that immutability is good, we should apply this immutability to the data that we persist in a database. The reason why we can't do it is that the database is a separate server living somewhere else, right? And so the way that Datomic approaches it is by rethinking, well, do we need a separate server at all? And I thought that was really interesting, because if you just look at it from only one angle or the other, like if you just become fixated on the architecture of Datomic, then it doesn't really make sense. But if you ground it in this fact that it's coming from this Clojure functional programming idea that immutable data structures are good, then it makes sense why you would have to fundamentally rethink the way that you structure a database.
Yeah. Yeah, and so like one of the reasons why immutability is good is because the by definition it doesn't change. And so we know as programmers like one of the complexities that we deal with is just managing state. And if there's no state to manage in the data, like so many things fall away and it's much easier. And so one of the things that introduce complexity is coordination, not just coordination between machines, but like coordination between different components inside your application. Because like what OOP likes to do is like we'll split the state of the application in different objects, and like if they have to coordinate then they sync, and so we have this like object graph of things that have to talk to each other, and we'll try to like compartmentalize it and use principles like the solid principle to minimize it and draw boundaries. But that still can wreak a lot of havoc complexity. But if you just have data that are values, and values are immutable and don't change, then you don't ever really need to coordinate because you can just pass things around. Like an example of a value is like 42. Like the number 42 will never change. So I can just pass it to you and you can work on the number 42, and I don't have to be any wiser, right? You can add to it, you can subtract from it. Like since I can't change it, like once it's out of my hands, it's out of my hands, right? And so it doesn't really matter. And so that idea is projected onto Datomic. And this idea is what enables it to scale reads. Because if you can treat the data in a database as an immutable value, then you can just ship it to clients or like whatever the working set that the client needs. And then the client can just do queries on that, and it doesn't need to coordinate with any of the other clients. Right?
Wait, what do you mean by that? So, okay, so you were talking about values, right? And how they don't change, and so you can pass them around. So why does that let you scale reads?
There was a study, I can't remember where I heard it from, but there was a study about like what databases are doing. The researchers were surprised to learn that a lot of the time, the work being done in a database is coordination rather than reading and writing. And this coordination is overhead that we don't actually care about. And so if you can get rid of the coordination, that is a win to speed up and optimize your reading and writing. And so one way you can do it is if you can pass the working set, like the data that a client needs to do whatever queries that it needs to. And so it's because immutable values can't change. So then you can ship that data, which you know won't change, to different clients, and then they can query that data without having to coordinate with me or with each other. Then you would be able to scale horizontally. Like I can just service as many clients as I want, and then they don't have to coordinate with me other than to get new data, and they don't have to coordinate with each other. And so maybe a good example is like a Git repository. And with a Git repository, all the different clients that are, when they clone the repo, they get an entire working set of the repo, right? That's their data. And they can do whatever queries they want on it. And they don't need to like worry about checking out code and coordinating with anybody else. Like if you remember back in the SVN days when like somebody checked out like a portion of the code, you were just stuck. And then sometimes people forget to check it back in, and then you'd have to like go ping them, say, hey, can you check it back in? And so that's a coordination problem. And it turns out that our databases actually do that a lot just on reads, right? And so when it comes to reads, like if you can pass immutable values, like then it's something where they don't need to coordinate with each other in the same way that like developers find distributed version control systems like Git such a hit because they don't have to coordinate with other developers about checking out files again. I mean, there's still some coordination because you have to merge your repos back in, but like that is less of an issue than like people stepping on each other's toes with check-in checkouts.
Got it. Yeah, that makes sense. And I think that's a good way to think about it. Like SVN had a server which was the sort of middleman. It was the arbiter of all of the data. You had to talk to it in order to update the repository. And everybody likes Git because of all the advantages you described. But for some reason, databases are still living basically in a world that's analogous to using SVN.
Yeah, exactly. And so now that you can ship data to clients, then architecturally Datomic can just scale out the number of servers horizontally to scale as many clients as they need to.
Got it. Yeah, that's pretty cool.
So I think that's one way that Datomic reduces complexity, because like in coordination, there's a lot of complexity. And we know that especially in distributed and concurrent programming, and databases are all about that, right? Because otherwise they're not really that useful if only one person can read or write to it at the same time. And so I think another source of complexity is that with traditional relational databases, we have gotten so used to the idea of reducing the round trip. Like we cram everything that we could possibly want into a single query. And for web developers, or I guess anybody that uses database, you should be familiar with like the N+1 problem. It's like where if you're querying for a list of blog posts and then you want to get all the comments that are underneath every post. And so for any domain data model, like you could have these type of relationships where you have a list of things that each of those have a list of other things. And so when you're doing a query for those, you have to know something about what the user might want. And if you did, you just want to get it all at once. And so this kind of conflates and does a lot of coupling to our systems, because like we end up having to cram everything into the same query.
Interesting.
Yeah, you have experience doing that sort of thing when you've built these sort of systems, right?
Yeah, I mean, I think the N+1 problem is actually most often you encounter it when you use things like ORMs and stuff,
right,
where it generates code that it does one query, and then based on what it gets back, it has to fetch a bunch of other things. And so, yeah, I think that people really hate on ORMs, but people use them for a reason. It's because the mental model of that ORMs expose makes more sense, right, in terms of when you're developing.
In the language of the programming language that you're in, like there's a certain affordance, right? Programmer affordance with it. But the other problem is just that you get N+1 problems. This also happens with GraphQL. Like GraphQL is really nice for the clients, but like when you're implementing on the server side, like it just pushes all the problems to the GraphQL servers, where you also get the N+1 problem as well.
Yeah. So people have had to work around this by, like, basically what you're saying is that we've taken it for granted that when you're talking to a database, you have to write a perfectly formed query that gets all the data that you need in one shot and brings it back to your code so that it can actually operate on it, which is not necessarily inherently true, right? Like you don't necessarily have to do it. We just happen to do it this way because of this historical accident that we're describing.
Right. And so as a result of that historic accident, like we don't like to do multiple queries across for whatever job that we're doing, because the atomicity of a transaction is only guaranteed for a single query, right? Like I don't think the database can like guarantee like the atomicity across multiple queries, like especially if you're like updating the database and stuff. And so as an aside, like one of the things that is a maybe potential retro episode that we can talk about, a HATOS, which is what, hypermedia application as a state, whatever that acronym is. But it's an interesting idea where you are browsing in hypermedia, that's the state of your application. But one of the reasons why I think it doesn't really work is because of this N+1 problem. It's highly impractical because of this problem. And as a callback to our previous episode, Hyperfiddle, this is one of the core realizations after the founder of Hyperfiddle used Datomic. And so he's just like, oh, if this doesn't work, there might be another way to do it. And so I recommend that you guys really check that out to see kind of what Hyperfiddle reimagines web apps to be. And I think like this is already a big thing. Like if you can get rid of these kind of coordination problems and round trip problems, you really can like make things a lot simpler. To me, when I kind of heard Rich Hickey talk about this, it took a while, obviously, but like once I kind of got it in my head, I'm like, oh, that seems to be a really big thing. Like, what was your reaction when you finally kind of had that aha moment?
Yeah, I think that I didn't realize how much of a Stockholm syndrome I was experiencing. Like as programmers, we internalize that things happen, or things are the way that they are, and we just work with them. And
so you rage against it for like the first couple of like weeks, if not like first few months, like for those of us that last so long. But then after a while, like it just disappears. and you forget what it was like. And then when you hear like newcomers come in, you're just puzzled, like, why is this hard? Right? And so sometimes these things are completely arbitrary. Like the things that are hard about something are just completely arbitrary, and you just kind of like picked it up. Right?
Yeah. So I think that databases are one of those things, like where it's like, well, all this stuff is completely arbitrary, and
well, to be fair, like the core theory behind databases is rooted in like set logic, so that stuff isn't arbitrary, but kind of the mechanism and the architecture around databases is actually they're specific design decisions made for a specific age and context at the time, and we don't realize when the world has changed, right?
Yeah, basically. And so I think that Datomic is really, really, like you said, thinking about things from first principles. And when you think about it in that way, I think they've come upon a good realization, which is that we don't need to necessarily have our hands tied due to all of these historical decisions. If we really want to solve a problem, or if we really want to solve all these issues, and we're willing to rethink everything and take some sort of controversial decisions, like you said, single-threaded writes and queries that run on the clients and all of those things. I think that you can actually reduce complexity, like you said, scaling reads, reducing round-trip problems. All of those sort of go away if you're willing to let go of the historical baggage.
Yeah. And so I think that the other interesting angle about Datomic is the immutable database part, the other aspect from the user point of view, where Datomic models information as a collection of facts. And when you get a new fact, you just add it to your collection of old facts. And like your new fact doesn't destroy anything that you knew before. And so you just kind of keep accruing. And one of the things about computers now is that storage is relatively cheap and memory is relatively cheap. And I remember the first time I heard about Git, I'm like, it just keeps growing and growing. But when we run out of disk, as it turns out, like I've never really heard of like people running out of like memory on disk or like for Git. And I think same is true for a lot of the other data that we have. And so it's only like the really, really, really massive scale companies that would have to kind of rethink and do things differently, right? Like, for example, Google, as we all know. And so when you have a collection of facts, like one of the interesting things about facts is that knowledge is derived from comparing and combining facts, especially in different points of time. Because like most of our databases don't have any sense of memory, because like when you update something, you update it in place. So it's kind of like, it's a very Zen version of data and knowledge about the world, in which you only understand and know about things that are happening now and today, right?
Mm-hmm. Yeah.
Right? Like it's always present. Like current relational databases are always in the present.
Yeah, that's an interesting way of thinking about it. Yeah, and you know, it is kind of weird that we just accept that data can change from underneath you, right? Like this is not a very like sane or principled way of thinking about data. We've just sort of, again, Stockholm syndromed ourselves into accepting that, like we're going to work with systems in which the data can change arbitrarily while we're, still working on it.
Right. And so we introduce all sorts of coordination mechanisms to solve that problem. And like the very way that we developed code is in this manner before like a lot of us got into version control, right? Like we would just kind of update things in place. And if we like messed up and couldn't debug it, we're hosed, and we start commenting out half our code and then another half and then another half, right? And so like nowadays, I think everybody would agree that that's kind of an insane way to work on your code base. And most people would recommend learning some kind of version control, but that's very much the way that a lot of people worked for a long time, even well into like the 2000s, like the places outside of Silicon Valley, right? And so it took a while for that to come out. So this idea of like accretion of facts and then using your body of facts to generate knowledge by comparing, combining these facts is a very logic programming way of looking at this. And so logic programming, as some of you know, is like languages like Prolog and Tree. So have you used Prolog in industry? Like I know people like touch it in college and stuff, but I don't get the sense that logic programming is really used that much in industry, like maybe some corners here and there.
I have actually, I mentioned in our data log episode that I have used logic programming for my work, but in a very, very obscure setting. It's generally not something that people know about. Most people that work in the industry, if you ask them, they would probably tell you no.
Right. And so this is a great call out to our previous episode. We did cover data log in our previous episode. So for those of you that are curious, you should check it out. But like the reason why we talk about this is because Datomic, in its weirdness stemming from first principles, is that it doesn't use SQL as its query language. It actually uses Datalog, which is a variant of Prolog. And one of the key things about Datalog is that it's not Turing complete. And so as a result, it's guaranteed to halt. So imagine a query language that just like would not halt. Then you'd be like, oh, I don't know what to do with this. So then as a result, like you can view the Datomic database as something where you can get a copy of the database, just like you can get a copy of a Git repo onto your client. And then it'll maintain that synchrony with the server for you. And then you can just query data locally as if it was on your machine, no problem. And so that's what it feels like to use it as a user on the read side. And then I think the other side we mentioned about the write side is that writes, however, are serialized. And I think basically it just simplifies the architecture for them so that they don't have to worry about like what happens if like these two things happen at the same time. If you just serialize it, that's okay. And so I think for people that have used Datomic before, like on HN, like digging around people's experiences with it, I think like most everybody agree that like reads scale really well, but if you have like a really write heavy application, then Datomic's like not the right thing for it. But like it scales better than what you would think because they separated the APIs for reading and writing and it to like two different parts of the system. Like they're not just two separate APIs, but like two types of nodes handle those different things. Then the node that is handling the writes, that's all they do. They don't have to handle coordination. They don't have to handle reads. They only work on writes. And so it works better than you would expect from the write performance that you would understand from traditional relational databases.
Yeah, and to be fair, most applications are way more read heavy than write heavy. Yeah. So I think that's a fair trade-off to make, especially for web applications where most of the time you're serving the data and only some of the time are you updating that data.
Yeah. So one of the interesting parts of our segment is now that we know what Datomic is, like what are some of the second and third order effects if this idea was more prevalent and everywhere? And so this is where we get to some of the fun. Sri, are you ready?
I am. Let's get into it.
Right. And so I think this model actually hints at something that can change the architecture of web apps or like even mobile apps. One of the things that web apps do terribly today is like the offline feature. Like once you're disconnected, like you're, I don't know, like you just can't do anything. And so the assumption that you have a network is a very first world luxury, or like, you know, like you've just never had the power go out before, right? Or like you've never worked on the plane. And so in the same way that developers can work on their code base because of Git, like imagine if you could do that with all your other applications, like with your Google Docs, like I still can't get Google Docs offline mode to work properly. Have you?
No, there's always some problem or the other. And yeah, I mean, I think this is a good, does this relate to maybe like local first software? Do you think
this
could
it definitely
enable
does.
This?
And I think local first software is, what was that, our second episode?
Yeah.
The memories. But yeah, I think this is one of the, so for those of you that are curious about local first software, you should check out the episode. But in short, it's a style of application programming and architecture in which it espouses that the user own the data that they work on. And so no longer would you have data on the server that you don't own. And so if the server shuts down and stuff, then you're like shit out of luck. But like if you have data on your own machines locally and you're just syncing to the server, you can always work on it. And so that's kind of maybe like a 2-line summary on local first software. But yeah, like one of the things that Datomic enables is this kind of architecture. But not only that, because it's written in Clojure and Clojure is hosted on the Java Virtual Machine, the JVM, that means any of the other JVM languages should be able to leverage it as well, from like Scala to also Kotlin. And Kotlin is one of the major languages that people write like Android applications with. And so Android developers that use Kotlin should, or actually any JVM, they should be able to leverage that. And Java, of course, right?
So actually, does Datomic right now, is it a common usage pattern to enable your actual end user applications to directly access the database, or is this something that it could enable, but it would require some more work?
No, I think it's available, like as long as you can connect to it, you can get, or you have a library for it, right? Because you definitely need something on your end as a client to be able to host the data. But once you have that as a library, you should be able to do it.
Interesting. Yeah, in that case, actually, I wonder how like access control would work, because obviously if you can directly connect to the database, you can read all the data that's there. But yeah, I mean, I think also I'd be curious to see how they address that. But there are also many applications where it's not necessarily a huge issue.
Yeah. And so I think today, one of the, I think there's a whole bunch of people that are using Datomic, but it's like smattering here and there, like Roam Research, for those of you that are avid second brain note takers, they built Roam Research on top of Datomic. And like, if you go to the Datomic website, they have a list of their customers as well. I think the interesting things is what it enables. And so going back to this kind of local first software offline mode, I think like various people that write on the internet about like web applications or interactive programs have kind of talked about it in various ways. So there's the article called The Web After Tomorrow, or APIs about policy, database in the browser aspect. Have you read any of these or heard of them? Like we'll put it in the show notes.
Yeah, no. This is all quite new to me. Like
okay.
I'm actually like having a hard time like imagining this, because again, this type of architecture is so novel. Like we're so used to thinking about
database in the browser, you mean, right? Like an
having a database in the browser. Yeah. Like because we're so used to thinking about there's a client, there's a backend, and then there's a DB, and now with this, it seems like you can merge a lot of it together.
Yeah. Like, I think it's something that people are still thinking about and playing with, but the idea is actually kind of old. I think, like, when did Web After Tomorrow, when was it written? I think it was like 2015 or something, maybe 16, 2015, yeah. And so it's been like 6 years, and it's still not quite caught on. Maybe the guy is just too far in the future. He was Technium before before we came around, I guess.
Yeah.
But yeah, like one of the things about the post on APIs are about policy that I talked about is the observation that a lot of times we have now a database server, an application API server, and then clients on the browser. And as clients become thicker and thicker, then the back end API is just something that enforces policy, like who can access what, and like kind of a sense of like, what are we doing? Like, and a lot of times we think about like, well, there's probably good reasons why we don't connect directly to the database, X, Y, and Z, policy, that sort of thing, security. But like when you think about it, it doesn't quite make sense, right? Like if the only thing that you're doing is enforcing policy on the back end, you could conceivably simplify it a lot just by cutting it out and putting that onto the database. But we don't do that, right? And I think a lot of it is because like database features don't really fit well into any programming language, like materialized views and that sort of stuff. Like ORMs usually don't touch it or support it really, and so you end up having to write raw SQL queries to kind of manage any of that.
Yeah. I think the closest that I've seen to this is something like Firebase, where the clients are directly talking to the database, and there isn't something in between. In that case, I think they figured out a good way to solve the access control so that you can only access the parts of the data structure, the DB, that you've authenticated into. So it sounds like at least the access control aspect is solvable one way or another.
Yeah. And I think the access control is no small task, right? Like anytime I'm asked to implement access control, I'm like, here we go. Like it can get full blown and complicated. And so it's definitely no small task, but I think it's definitely solvable. And having the database in the browser, I think makes a lot of sense, because the user experience for the developer, it just feels like you have the data on your own machine and you just query it whenever you want.
Yeah, I think that model really resonates with people. Like, people liked Firebase, and it caught on very popular, or it gained a lot of popularity because as a mental model, it's just intuitive that way. Like, why go through all of this extra song and dance routine if you could just treat your data as though you had it all along and just traverse it like you would any other local data? Yeah,
so this new architecture with data in the browser, which like simplifies the complexity in like web apps, which are distributed apps, and the ability to support offline mode much more easily are kind of the two things that jumped out at me as second and third order effects. So what about you? Like, what are some of the things that you thought about when it came to like what this sort of thing enables if it more people were aware of it?
Yeah, I think that this isn't quite an effect, but one interesting way I found of thinking about Datomic is that every once in a while, if you go to Hacker News, people will write about how they wrote their entire business logic of their application in stored procedures in a database.
Oh, yeah. It sounds crazy, right? Like somebody like wrote an entire application in the database. And it's like a really weird thing for people coming from traditional like web frameworks. It's like nobody tells beginners, all right, you want a web app? Let me teach you about stored procedures, right? No, they say like learn some Python or Ruby on Rails or something.
Yeah. So, I mean, and it is, I think it is a bad idea to do it using traditional databases for a variety of reasons. But basically the reason why people sometimes go down this route is because it makes intuitive sense if you think about it from first principles, that your logic and your data should live together, right? Like your application is the combination of your logic and your data. Yeah. And it does, like, why would they not be in the same place and be able to access each other pretty in a lightweight way? And so stored procedures is one way that you can co-locate your logic and your data. Now, the problem with this is that, the code for stored procedures, you write it in you have to write SQL, you don't get version control, you don't get IDE, all of the stuff, right? So you lose all of the nice things, the tooling that you get with the regular programming language. So it is a bad idea. But I think what Datomic is saying is, well, we can co-locate our logic and our data if we do it in the opposite direction, right? You bring the data to your code, you don't put your code in your database. And so this gives you the advantage of that co-location, but allows you to continue to write your logic in a regular programming language like Clojure, which of course has an IDE and all the tooling that you're used to.
Pause. Do you wonder, just to hold that thought for a second, do you wonder if maybe we should have built a lot of the tooling around stored procedures? Because maybe if IDEs could work on stored procedures, or if you built a version control into the database, you would be able to work on stored procedures. Because I think actually like Git is modular enough that you can build a back end that is based on a relational database rather than the file system. And so you could conceivably do that. So maybe like if the tooling was better, I don't know.
And I think actually some people are trying to bring stored procedures back. In the research for this, when I had this realization, I found this project called Postgres, which is basically trying to make Postgres into your API server. So I don't know, that the people I think are working on this on the other end of the spectrum too.
Woe to that guy that has to describe in a loud bar like what he works on. Postgres. What?
Yeah.
Postgres? Yeah, I don't know. So then Datomic really just goes the other way. And I think there are some things where there are some question marks about how it does that sync and ships over the network, but I think it seems to be able to do it perfectly fine because like most of the testimonies that I've read and from what little I played with it, like it just doesn't seem to be a problem for syncing the data from client to server. I think a lot of it is just the immutability of data, right? Because like once you ship over something, you don't need to ship it over again because it'll never change. It's immutable, right? Mm-hmm. And so I think that simplifies things a lot. And like the clients can just cache it once they get it. Like cache invalidation isn't really a problem, like in the sense that like, should I keep this around because it's changed out from under me? The decision now is just like, do I need this piece of data rather than has it changed out from under me?
Yeah. I mean, actually, we'll put in the show notes some of the resources that go more into the architecture of Datomic. Yeah. I think the interesting thing to keep in mind as we describe all this is that there's a naive way of implementing this, which is going to perform as horribly as you might imagine. But with a lot of functional programming concepts, they provide a like logical mental model that and a set of affordances that it exposes to you, but the implementation is optimized in a variety of ways so that you're not always, copying data around unnecessarily and or just shipping everything and dumping it to the client. They have a variety of optimizations so that under the hood it's doing some other stuff.
Yeah, I mean, it's the same way, like if a lot of us use Gits and like each commit logically is a separate thing altogether, but underneath the hood, they actually share a whole bunch of data so that you're not just blowing up your disk. Yeah, so
Yep.
so then kind of going back to what do you think it enables? Like, were there kind of other things that you thought about as a result of like having this kind of newish architecture? Like we talked about the offline mode, the local first thing, and even like our previous episode on hyperfiddle, like the realization that maybe you can write code for both the server and the client in the same piece of code and then have a compiler like carve that network out from you was as a result of using Datomic and coming to that realization.
Yeah, I think that one interesting effect is not as much of a technical consideration as much as it is a cultural one. So I think one of the things that prevents people from really harnessing like the power of computing or like, and programming is that, let's say you take an intro to Python class or intro to programming class, and you can do some toy exercises and solve some problems, right? That's great. You feel good. You put it on your resume or whatever that you can write some code. But then in the real world, in order to actually do something, you have to learn this whole other set of concepts of database access, writing SQL, which is kind of a weird way of thinking about data that isn't how you normally think about data when you're just writing normal code. There are all these weird things, right? And so there's a separate step where like there's a gap between being able to write toy code and being able to write real code. And so I think that one effect that something like Datomic or this architecture that you're describing, if it becomes more prevalent, is that it closes that gap where it gets to the point where if you know how to write your application logic, you can right away be empowered to access the power of a database. You don't have to like learn this other second set of things that is like a secret thing nobody ever taught you.
Well, you do have to learn data log, but
yeah, that's true. Yeah.
But I get what you're saying because like if the data feels like it's on your machine, it feels more, there's less of a impedance mismatch. Like that's what you're getting at, right? Like we've discovered that there's this weird impedance, and we've tried to like what was OARMS described as the Vietnam of computer science, because it's just something that people poured like hundreds of thousands of man hours into, and still not like a solved problem. That impedance mismatch, and so this at least was a fresh take on like some other way out of this kind of weird quagmire that we found ourselves in. Yeah, I thought you were, when you said like the effects were going to be social, I thought it might have been different things, kind of the types of applications that you can build with this kind of architecture. And this kind of points more to local first type of software. And I think in that episode we pontificated on like the types of local first applications. And I think I remember that what I said was it would have to be applications in which you want to work on your own stuff, but like you still need a community of people to like do that stuff with. And so I guess that's like usual, I just say something like generic that makes no sense. So concretely, maybe something like document sharing, like you're working on documentation. Weren't you the one that said like having somebody watch you write a Google Doc is like one of the most intimate things in the world nowadays?
Yeah, I get stressed out.
So maybe enable a little bit of that, but yeah, I don't know like what the update time is for that sort of thing, because I don't think it's like an operational transformer like a CRDT sort of thing with Datomic. But when it comes to applications, I think that you can have a copy of it on your hard drive. I guess maybe if we were to like think by analogy rather than by first principle, like how has Git transformed like the way that developers think about their code and how they work? And maybe that's analogous to like other types of applications that could leverage this sort of thing, right?
Yeah. I mean, one thing is just the idea that you don't go through a separate server, right? So you actually just like make the changes locally, you commit them, and then there's a separate step that propagates this. And so that's like, I think that's the biggest change in how Git has changed my view on version control. Like this,
it's not that you can code on the airplane.
Well, yeah. So I mean, basically, the mental model that distributed version control gives you is the same as what we're talking about. Is that your code doesn't live somewhere else, right? Like when you think about SVN, you're checking out. Like even the verbs are kind of weird. Like you're checking out the data. Like you're checking out a file, kind of like checking out a book from a library, but like it belongs to that server. You're checking it out temporarily to do something about it.
You're
So there's
obtaining the lock, basically, right? Yeah.
Yeah, basically. And so it makes it so that the code lives somewhere else. It doesn't live where you are, which is on your own computer. And so that was the biggest like mental model shift.
Right, but how has it affected the way that you worked?
Yeah. I mean, I think being able to code, when you're offline or even you don't actually care about your connectivity at all until the point where you actually do need to synchronize. That's the big thing. And I think there's also, you gain a lot of the tooling that works with like local files, works with something like Git. Whereas I think with like SVN, if you wanted to do anything, you would either have to have like your tools would have to be like aware of SVN versus like if you just had all your source code locally and you could just access it with whatever tools you want.
Yeah, come to think of it, like with SVN, if you wanted tools to analyze like who did how many commits, or like you couldn't write like a tool like gsource without putting load on the SVN server, and nobody on your team would want that. Like who the hell's eating up all the CPU time? But like for something like Gorse, like it's like a visualization of like, I don't know, like your source tree and like who's editing what over time. Like you can run that on your own computer. Then that kind of points me to the same feel that maybe small talkers have in their development environments, where they have all that stuff at their fingertips and they can manipulate their system, because like the programming environment is the system. And maybe here it's more that the data is always at your fingertips, so you can do whatever like monitoring or analysis that you need for your application because the data are already right there.
Yeah. I think that's a pretty big change. Like right now, the database is a black box, right? Like it's this thing, it's a special hallowed thing which you as a programmer don't want to touch, right? And it's actually something kind of like Smalltalk, where Smalltalk closed the gap between your applications and the operating system, right? By kind of exposing it, and so you can write your own tools that observe into the running of your operating system, right? And write like debugging tools and things like this. And I think that if a database is also not a special place with its own special incantations that it needs, but instead lives alongside your application, then in effect you can extend and compose and write your own tools that can, like you said, analyze your data, monitor your data, plot it, I don't know, anything, right? Without having to go through some special procedures.
Yeah, maybe like what usually in other ecosystems would be like a VC-backed startup really is like a library that you can use. Like I'm half joking, but like I guess that's kind of the idea or feel that we're going for, I think.
Yeah. I think that's a good way to put it. Like because and the reason why it would have to be something like a VC-backed startup probably is because you need special engineers who can like have the abilities to build that kind of tooling. Versus if it is something that your average Joe programmer could do, then it doesn't need to have all of the structure around it.
Yeah, and so I think that's kind of a weird change. Yeah, because like I'm trying to like put myself in the shoes of like an SVN developer and projecting out into the world of Git or something like that, and I guess you can only see so far. Though, like if you do look for it, there are instances of where people talk about using Git to a whole bunch of people that aren't used to it before, and they have a hard time convincing like SVN users of this. And I think it's going to be a long slog probably before I think this is accepted as a common like. But of course we do it this way.
Yeah. So actually, one thing that came to mind is that basically the way that the mental model that Datomic exposes about your data, which we've said at this point a few different times, is that your data feels local, right? And so, well, there are databases in which your data is local, namely something like a SQLite. And there's actually a variety of tools that actually is a growing community around using SQLite, and they're making a lot of interesting analysis tools. Like there's this project called Dataset, which is a tool for exploring and publishing your data, which is stored in SQLite,
Right.
and they have a variety of plugins that can visualize your data, that can render your data in a variety of ways, expose it as a API, or ship it around to other folks so that they can also view the same data set that you're viewing. And the reason that you can do this with SQLite is that SQLite is just a file, right? And you can ship that around to somebody and say, hey, like, let's look at this data together on our separate computers without having a server in the middle to coordinate. And so, of course, there's some limitations to SQLite because there's only so much you can do storing all your data on a single file. But if you have a Datomic setup, then you have the logical advantages that you would with something like SQLite. But in fact, you're not constrained by only that data that you can fit onto a single file.
Huh. Yeah, actually, that's kind of interesting you draw the parallel, because I think one of the things that the creator of Dataset, Simon Willison, said was that he figured out that while everybody kind of poo-poos SQLite as kind of a toy, or maybe like things for mobile apps to use, it's kind of a small database. It actually scales reads quite well. And so if you have just a file for the SQLite and you need to just scale reads and don't worry about writes, like it actually does really well. And so therefore you can just throw dataset on top of it and ship it around. And it's basically database as a value, but in the form of a file.
Yeah. Yeah, I think that's the thing, is like it is a database as a value, and you can ship it around. And the thing that Datomic buys you is that the database is a value, and you don't actually have to ship around a file. But
right, like that's the syncing is taken care of for you in the background. Like all that mechanism is taken care of for you.
Yeah, exactly. And so actually one of the things that something like SQLite and Dataset, like, I think it's popular among not necessarily the programming community, but with kind of like data scientists and analysts and these types of folks, because they're not necessarily, they wouldn't stand up a database and do all of this extra work. But if they can ship around a file, then they can kind of collaborate on data. And actually, that's one of the things that Git has sort of also changed the way that people work. I think Git allowed code to become kind of a social artifact that everybody can have their own copy of and look at collaborate on, right?
Yeah.
And so analogously, the databases of value and Datomic allow data to become an artifact that everybody can take look at together and collaborate on.
Oh, that's pretty interesting that you frame it like that. Then I think you could have like different subcultures of data where people collaborate and really care about like a specific set of data. Like data is really broad. So like, what if there are people that, I don't know, really care about train schedules? I think there are those, right? Like there are people that collect bus tickets. There are people that like annotate like the train schedules and like which train left at what place. And so like if they were able to share that together and kind of build applications around that data, it's almost, I wonder if you could conceivably have a peer-to-peer web application where you ship the data around between peers, and you could optionally have a server that this coordinates on. But if you have that, then it's like a community of people passing around, almost like Where's files way back in the day.
Yeah,
right?
yeah.
Like it's that same sense of like, oh, okay, like we all have this common thing. We just need to kind of sync it up.
Yeah, and I think like something like that, train schedules or some database of, I don't know, like different types of fish or something.
Maybe a more compelling example would be, say, like a list of blacklisted like ad sites or something like that for like ad blockers. Maybe that would be more compelling, right?
Yeah, and actually people use GitHub in this kind of way increasingly, where they use the tools that we have for source code, but they use it to maintain like a collaborative list of, like, I think ad blockers is a good one. They have like a list of patterns, URL patterns to block, and they do this by updating a text file, right? But I mean, there's some type of data that could very well, like, it's simple enough that you could use Git and our usual text-based representations to manipulate. But if you think about other types of more complicated database that's more structured, you wouldn't want to use GitHub in that way. And so I think one effect is however people are using GitHub to collaborate on simple types of data, you could also collaborate on arbitrarily complex data that has multiple different types of entities and relations between them, and you could collaborate on that type of data as well.
What do you think would be an example of that kind of data?
I think
only things that I can think of right now are like really niche, like the list of all museums in the US, like from the lava lamp museum to the, I don't know, like soda bottle museum or something like that. Like definitely there are fans of that. I mean, personally, I watch the Marble League, and so I wish there was like a database with all the different times for all the different Marble teams, but like but like that, I guess maybe that's the equivalent of how there were like niche forums way back in the 90s and 2000s where people kind of collaborate in a forum, like, and I guess their artifact is maybe like a wiki, perhaps, that sort of thing.
Yeah, basically. Yeah, I mean, there's a ton of things that you could do. So some of the examples, like on the dataset site, are things like keeping track of election data, COVID cases, this kind of like social impact type stuff. And so where people might want to maintain a record, right, and have that be a public good. And so, and I think that those are the kinds of things that they're small enough that you could just use SQLite for, but things can get much larger. So suppose that you wanted to have, let's say, all of the products in the world, right, a database of all of the products in the world and their who sells them, their UPC code, their prices.
Yeah, that would be very
like
valuable, actually. There are a lot of sellers that want that sort of stuff.
Yeah, and so with that kind of data, because that data is, one, it's hard to acquire, and two, it's hard to collaborate on data, what happens is that type of thing is, these days, sold as a proprietary artifact, right? Where one company gathers all of this information and then exposes it via an API for money or something like this. But that doesn't necessarily have to be the case if we have a public database that people can connect to and update and collaborate on. That kind of thing could become a public good as well. Things like that, nutrition data about foods, these kind of things that where the size of the data could be substantial, but you would still want people to be able to work together to accrue those facts.
Yeah, but then I guess the only like so-called public database that I can think of that is relatively successful is Wikipedia. But then, like, I'm not. Well, there's the Google Knowledge Graph, but that's owned by Google. They were like, it's subsidized by Google, right?
Well, so the Knowledge Graph, the Google Knowledge Graph actually came from a company called MetaWeb, and the initial version of MetaWeb was free and publicly accessible, and it was in a very permissive license. And so actually, in its original form, it was very much similar to what we're talking about. Of course, I think it failed because there's no business model around that. But why does there need to be a business model around everything? Well, because right now, in order to collaborate on data, you need to have a centralized entity that is, maintaining a service around it, because they need to control the database, right? Whereas maybe in this new world, this could be a public good that people crowdfund and collaborate on without having a middleman.
Yeah, I mean, maybe. I think that is always a thought, especially for users of something. Like, I like things that are free and a common good, I guess, because it helps. It's like a baseline for you to build other things on top of. But like sometimes inevitably you get, well, I mean, GitHub is a good example. Like Git technically doesn't really need a centralized things, but they built out all sorts of things that were adjacent and complementary to Git, such as like the wiki and the issues and stuff like that, and they built a business out of it. And so maybe for every niche that is out there that can be profitable, I don't know if train schedules can be profitable, but like other things where there's a niche, there probably may be a business around it where you build the complementary and adjacent features to that data set that people are passing around as a value.
Yeah. And actually there could be a value added service like GitHub for something like Datomic, where there could be issues. Why can't there be issues on your database? Like, hey, we need some more data here about this thing, and then people can collaborate on that. Like, actually, I think there's room for an analog of GitHub for your database.
You heard it here first, folks. Get on that. That's another startup idea. You might just be too early. I don't know. You just got to raise some money and hang in there. So we'll see. I mean, like, Datomic has been out there for, I don't know, 6-7 years, if not more. So it'll take a little while. Probably not too much longer, right? But you do have to do a bunch of education because this is still a relatively new idea. Because if it weren't, we wouldn't be covering it on the Technium. So with that, I mean, I guess, like, I'm pretty excited about this. I think, like, the complexities, I'm familiar with the complexities of building web apps. And the more that I do it, the more that I'm looking around for ways to simplify the complexity. And it makes me think that there's maybe another way to do this.
Yeah, I think that more programmers should, think about programming from first principles. It's hard. Because there's so much baggage that we've internalized. But I think
just that it's hard to, like, first principle everything. Otherwise, you just won't ever get anything done, right?
Yeah. No, so obviously it's a tool, right? You can't just first principle everything. But it's also hard because it requires so much effort. And so I would say that things, even if you don't write Clojure and you don't use Datomic yourself in your day-to-day work, I think that one reason I'm excited to talk about it in this episode is because it's one of those things where I feel enriched as a programmer because, like, I have a new perspective on the world of computing.
I guess that goes along with its Lisp culture, because a lot of people say that programming in Lisp, you'll never use it, but it makes you a better programmer overall. Is that the sense you get with Datomic?
Yeah. It's exactly that.
So with that, our optimism and enthusiasm is out of this world. I know definitely for me. And so how's it for you?
Yeah, I'm super enthusiastic.
Yeah, I'm stoked to have more people get on this train because, like, I think it could really simplify a lot of things about the web applications that are so pervasive in our world today. If this episode opened your eyes, check out our other episodes where we talk about the other edges of technology, why they're interesting, and the future that they point to. Check them out and subscribe. Hit that subscribe button. We don't like likes. We want subscribes. And be sure to check out our other audio versions on Apple Podcasts and Spotify, and write us a review to help bring other Techniumistas on board. And with that, this is Will signing off, and
this is Sri.
All right, we'll see you next week on another episode of the Technium. Later.